Today I'd like to share with you the SINEMA Remote Connect platform from Siemens. Using the SINEMA Remote Connect platform, we can establish connections to remote endpoints over the internet or a network. At the heart of this system are the scalant switches. The scalant switches act as the endpoint in which we can establish a connection to. For example, on the board behind me, we have a scalant switch at the top, which is separated into two virtual networks. The top virtual network is our network for our entire room, which is internet facing, which is what we use to connect to the SINEMA Remote Connect server. The other virtual LAN at the bottom here is what we call our internal LAN. So this LAN is only accessible from this board here. So we have two completely isolated cells. Now, using SINEMA Remote Connect, from a remote location, I can establish a connection directly to this scalant switch, and then I'll have access to everything which is on this board. So what this means is, from a remote location, we can start to access the web server of the power supply unit. We can access the OPC UA server on there too for energy data. We can obviously access the S7-1500 PLC using TIA portal. We can also access the web server of this device, as well as the OPC UA server, and we can also access the comfort panel over here. So using a built-in mechanism called Smart Server, we can establish a connection to the panel, and we can have a remote mirror view of what is being displayed on the screen. The ultimate goal of the demo I'd like to show you is we have the capability to connect into this cell remotely and run this demonstration from a remote location, viewing it over webcam. The demonstration we have here is a 1500 key processor controlling two V90 drives, with the synchronizing and slave axes down here with gears connected to them. So when we start this demo and give it a speed set point, what we'll see is the first gear start, the second one ramp up, they synchronize together, and then as we increase the speed set point, the two axes will stay in perfect lock. So what we'll do now is we'll head back to the home office and we'll connect to this cell and we'll demonstrate some of this functionality. Now that I'm in my home office, we can use SINEMA Remote Connect to dial straight into the scalant units in the demo room. Inside the demo room, SINEMA Remote Connect server is running as a virtual machine. All the scalances on the room will connect to that, and then using the corresponding SINEMA Remote Connect client on my field PG here, I can establish a VPN tunnel to a scalant of my choice. So we'll have a look at that now for the purposes of demoing all the equipment which was on that wall which we saw previously. On the programming laptop, we run the SINEMA Remote Connect client. We're then greeted with the login page where we put in the URL of the SINEMA Remote Connect server and our username and password. In our application, the SINEMA Remote Connect server is running as a virtual machine in our demo room in Manchester. Once the connection is established to the server, we are presented with a list of the scalant switches that I have the privileges to connect to from my user account. First of all, we need to establish a VPN tunnel to the SINEMA Remote Connect server. Once this connection is established, we can then choose which scalants we want to be tunneled through to. We can choose as many as we want, but in this application, we are only interested in the advanced automation cell. As soon as we click yes, our traffic is then routed through to that particular scalants. From my programming laptop here, I can now access everything in that 203 range. Using a web browser, I am able to access the IP address of the PLC, and I'm greeted with the PLC's web server. We can use the web server for remote diagnostics and troubleshooting. For example, we can click on diagnostics, and then we can see the current status of the controller. We can also access the web server of the power supply. This can give us interesting information, such as the incoming voltage from the three-phase system and the load that we are placing on it. We can also use OPC UA clients to establish connections to servers in this cell. So here we have the OPC UA server of the S7-1500 PLC, and now we can browse the memory space of that controller. This includes the data blocks, the marker memory, the input and the output area. If we need to go online for fault finding, we can use TIA Portal. Here I have the TIA Portal project open that corresponds with the cell that we saw earlier. We can see here that we have our main controller, so we can establish a connection to it. Once we have connected to the controller, we get a nice representation in TIA of the health status of the system, just as we would if we were physically plugged into the device. Using TIA, we can also browse some of the PLC logic. For tasks that involve remote troubleshooting, this allows us to look through the PLC code and see if we can find a reason why we have got an issue with our control system. For the purpose of demoing our application, here we have a data block which simulates the values and the inputs that the PLC expects to receive from the push button station. When in the online view, we can manipulate the values in this data block to simulate presses of buttons. Using the webcam we have installed in the demo room, we can now see that the gears are engaging, synchronizing, and once we change the speed set point, will slowly ramp up. We can also use the smart client to access the smart server infrastructure of the comfort panel, and we can then get an accurate depiction of what is going on with our demonstration. So I hope this video about SINEMA Remote Connect has been helpful. If you have any further questions or comments, please just drop me a message. Thank you.